All right, you're welcome to this class. You're welcome to this live class. If you can hear me and you can see my screen, can you just kindly type "I can hear you" in the comment box so we can commence as soon as possible? So you can hear me, you can see my screen. Type "I can hear you." Okay? Type "I can hear you." Type "I can see your screen." Okay, I need to be very short so I would know that I'm communicating and there are people out there who can actually dialogue with me, who can actually communicate with me via the chat. So text or type in the comment box, "I can hear you." I'll be waiting for your responses. All right, I can see your responses. Okay, you can hear me. Good, good. Okay, so in today's class we are going to be looking at very crucial areas. If I were you, I would stick till the end of this class. All right, very crucial areas that it's related or that are related to your exam focus. Okay, so basically these are areas that are very very crucial, and of course we'll be tackling them. So like I said, stick to the end. Stick to the end of this live class. Okay, stick to the end of this live class. So this is still your tutor, Mr. Nisike, and this is Nisike Academia. If you've not subscribed to this channel, do well to hit the subscribe button right away and subscribe. Invite your friends, share the link to your friends so they can also participate in this class. All right, so in today's class we are going to be looking at a very crucial aspect of this course, which is like a major aspect that can never be ignored. It's called arrays. All right, it's called arrays. So we are going to be looking at arrays, and I'm going to be treating some areas that you probably struggled with while maybe having your personal study, and of course you will try to bring it to a compromise and ensure that everyone is actually on the same page. So what is an array? Okay, what is an array? So I'll be giving you keywords in the definition of an array. An array is an orderly arrangement. An array is an orderly arrangement of similar objects. Okay, orderly arrangement of similar objects, often in rows and columns. Often in rows and columns. Okay, now often so the orderly arrangement of similar objects, often in rows and columns, in the form of a matrix. Okay, in the form of a matrix. So these are like keywords. Okay, so what's another keyword? So in the form of a matrix, okay, whose objects are of the same size, okay, of the same size, data type, okay, the same size and data type, although the objects may have different values. Okay, although the objects may have what? Different values. Okay, so basically definition of arrays is that an array is an orderly arrangement of similar objects, often in rows and columns, okay, in the form of a matrix whose objects are of the same size and what? The same data type, although the objects may have different values. So these are like some keywords that you can easily use to remember the definition of an array. Orderly arrangement, which means that the arrangement is in an orderly manner. And what is the orderly arrangement all about? It's the orderly arrangement of objects that are similar, objects that looks the same. All right, similar. And how are they arranged? Okay, they are arranged in rows and columns. Okay, now you know how rows and columns are. Okay, you know how matrix is. So if we say in the form of a matrix, it means that we can have it like this. We can have it like this. Row is usually the one that is the horizontal. Okay, row is usually horizontal, while column is vertical. Okay, so column is vertical, while row is what? Horizontal. So if we have an arrangement like this, if we have something like this, where we have 5, 6, 2, 4. Okay, now what do we have here? This is row 1. This row 1. Why this what? Row 2. Then for columns, this column 1. Why this is column 2. Okay, so vertical like this is column, row like this is the horizontal. All right, so we are saying that arrays is an orderly arrangement of similar objects, often in rows and columns, okay, and in the form of a matrix, where the objects, these similar objects, they have the same size, they are of the same size, and they are also of the same data type. But the only difference is that they will have different what? Values. Similarity, difference. Okay, that is the only difference, that they have different values. So that's the definition of an array. That's the definition of an array. So one thing we must understand is that this array we are talking about can store collection of objects. Okay, collection of objects. And like we said, the collection of the objects, when we say collection, we're talking about like groups of objects, and these objects must be similar. That is the code. That's the key here. All right, that's the idea. It must be what? Similar. The collection must be of what? Similar what? Objects. All right, so one thing you need to also understand is that they are used in programming. That's why we are studying it in formula translation, that is computer programming. Okay, but it's often more useful to actually think of an array as a collection of variables of the same type. Okay, so it's more useful to see these objects you are talking about as variables. Okay, which means that they can change, they can vary. That's why we have different what? Values. In as much as they are similar, they can actually change. They can appear in different forms. Okay, so it's best to see these objects as what? Variables. It's very important to see these objects as variables, but they must have the same what? Data type, and they must be of the same size. So when we talk about arrays, we are going to be talking about dimensions of arrays. Okay, arrays can be one dimensional, have one dimension. Okay, they can be two-dimensional as well. Okay, and you can also have them as multiple dimensional arrays. That is, they can also be more than 2 dimensions. I'm going to explain what I mean by dimensions. Okay, all right. So but when we talk about these dimensions, all right, and we talk about one dimensional what? Array, there are ways that we declare these arrays. Just like I talked to you about how we declare variables and how we declare constants, there are also ways that we declare what? We declare these arrays, or these one-dimensional arrays, or two-dimensional arrays, or three-dimensional arrays. Okay, there are ways that we do that. Okay, so to declare a one-dimensional array, okay, this one-dimensional array is called a number. Okay, so to actually, that is, I'm giving an instance that we want to declare a one-dimensional array that is called a number. That is, the name of the array is number. Okay, first of all, we'll write the data type. Let's say real, for instance, is the data type. Remember, I taught you that we have real, we have integer, we have complex, we have also character, then we have logical. These are data types. Okay, so it's important to actually understand this concept. So let's say the data type for the one-dimensional array is real. Let's say that the data type is real, which means that they are real numbers. Okay, it contains real numbers. Let's say the data type is real, and the name of the data type is number, for instance. All right. Okay, so this is what we do. So we say real, then comma, then we say dimension. Okay, dimension. Then let's say we'll put a number, let's say 5. Okay, then we'll do this just like when we are declaring variables. You will put double columns and write the name of the array. Let's say the name of the array here is number. Let's say the name of the array is number. Okay, now one thing you need to understand is that the individual elements of an array are actually referred by using their subscripts. Okay, now the first element of an array has a subscript of 1. Okay, the first element of an array has a subscript of 1. We are having 5 here because the fifth element in this array, okay, have a subscript of 5. That's why we're having 5. So if we have a number in a one-dimensional array like this, okay, that one-dimensional array is being referred to as the individual elements. Okay, let's say we have 5 like this. Now it means that there are 5 elements in this array. The first element has a subscript of 1, second element has a subscript of 2, third element has a subscript of 3, fourth has a subscript of 4, fifth has a subscript of 5. All right, so it's very important. So the first element of an array has a subscript of 1. Okay, so it means that the first element of this array will be 1 down towards 5. Okay, down to 5. So it's very important to actually note this. Okay, so just see arrays as orderly arrangement of what similar objects in rows and columns, which are always in the form of a matrix. They have the same size, they have the same data type, but they have what different values. So that's a core and crucial definition that you must take cognizance of. All right, you must take cognizance of. So let's say we want a two-dimensional array has 2 dimensions. Like if you look now, the dimension here is just 1 dimension here, which is 5. If you want to write a two-dimensional array, let's say we have an array and the name of the array is country. Okay, country, and let's say the data type is integer. So we'll write it like this. Let's say we have integer, then we say dimension. Let's say we have 3 in the bracket, then columns, then we say country. Okay, then we say country. Okay, how many dimensions are here? There are 2 dimensions here. Okay, so one thing you need to understand is that arrays can actually be represented in any data type at all, but all the elements in that particular array must all have that data type. So it means that all elements in this array are all integers. All elements in this array are all real numbers. That's what it implies. Okay, that's what it implies. Okay, so we are going to be looking at some array related terms. So it's very easy for us to actually resonate with this. Okay, now we'll look at array related terms. Some terms that are commonly used in arrays. All right, so now number one we'll be looking at is what we call rank. Okay, it's what we call rank. So when we say rank, okay, what we mean is that we are talking about the number of dimensions that an array has. Okay, we are talking about the number of dimensions that an array has when we say rank. For instance, now this integer, this dimension that we have 3,3, and we have country. This one I wrote, the second one I wrote. If you look very well, it has 2 because it's a 2-dimensional array. So it means that the rank here is equal to 2. So this one is the rank is 1. The rank is 1 because it's a 1-dimensional array. So the dimension is the array. The dimension of the array rather is the rank. Okay, the dimension is what makes the array. Then the dimension there is what is used to represent the rank. So if it's a 2-dimensional array, it means that the rank is 2. If a one-dimensional array, the rank is 1. If a three-dimensional array, the rank is 3. Okay, that's what it means. All right, that's what it means. Okay, so now let me give you another example. Let's say we have real, then we have dimension here. Then let's say we have 2,6, and we have maybe the name of this matrix is algebra. The name of this matrix, because normally two-dimensional arrays are also called matrix. Okay, now our algebra, if you look at how many dimensions are here, 2. This is a two-dimensional array, so the rank here is what? 2. So the reason why I wrote, you might be wondering, why am I writing the same example? Trying to write the same example because some of you now may be thinking that the dimension in the bracket, they must be the same value. No, can be different. Okay, they can be different. Like these 2 and 6 are not the same now. 2 and 6 are not the same. Okay, so that is it. Okay, now number 2, the second one is what we call extent. We call it extent. So what is an extent? The extent of an array is the number of elements along the dimension. Okay, the number of elements along the dimension. I told you that this one is the number of dimensions. Okay, this one is number of elements along the dimension. Okay, along a dimension. Okay, now what do we mean? For instance, now let us still use this integer dimension 3,3. Let's say country. Okay, now if you look at this, we have this particular array here. Okay, the data type is integer, then we have 3,3 here. Okay, now the number of elements along the dimension here is actually 3. Now basically, when we are writing extent, it's very important to actually look at what we have inside the brackets. Okay, now if you look very well, we have what? We have 3 appearing twice. We have 3 here, we have 3 here as well. So the fact that 3 is appearing twice here, it implies that in both dimensions, because this is a two-dimensional array, both dimensions have what? 3 elements. Because now a dimension is 1. This is another dimension. So the extent here is 3. Okay, because if you look at this dimension, what are you seeing? You're seeing 3. Look at this other dimension, 3. So the extent here is 3. So the extent is you picking what is inside the array. If we have, let's look at this one we wrote here. When we said real, then we said dimension 5. The extent here is what? Is 5. The extent is 5. All right. So it's very important to understand this. Okay, it's very important to understand this. Now we'll be looking at some more related terms that are used in arrays. Okay, we've looked at rank, we've looked at extent. Okay, now the next one we'll be looking at is the shape. Okay, now when we say shape, okay, we are talking about the argument of the array. Okay, the argument of the array, more like what is inside the array, bringing out what is inside the array. Shape may be the same thing, may be like an extent. A shape may be like an extent. Okay, but when you talk about shape, you're talking about what is contained in the array. Okay, now if we look at this integer and we look at dimension again. We are just using these as examples since we have been using it all this while. Now we use this, we look at this. Now the shape now is 3,3. That's the shape. This is the shape. Okay, this is the shape of the array. Just bringing out what we have inside the dimension. Okay, bringing out what we have inside the dimension. If we for instance now this real dimension 2, 6, the shape is 2, 6. That's the shape of the array. All right, the shape, what does when we say shape, what does this thing look like? Okay, what does it look like? It's just you bringing out what is inside the array. So 2,6 is the shape. The shape for this one is 5. That's what shape. So shape is also called the argument of the array. The argument of the array. That's shape. Extent is the what elements along a dimension. That's extent. The number of elements along a dimension. The rank I told you is basically the number of dimensions that an array has. Okay, number of dimensions that an array has. Okay, now the next one we'll be looking at will be size. Will be array size. Okay, well, can you hear me? Let me know if you can hear me and you can see my screen. Okay, I need to be sure. Can you hear me and can you see my screen? If you can hear me and you can see my screen, can you please type in the comment box? All right, so I can see your responses. Okay, let's proceed. Like I said, we'll be looking at what size. Looking at size. So now, what is the size of an array? The size of an array is the number of elements an array contains. Okay, please don't confuse it with rank. Rank is the number of dimensions that an array has. This one is the number of elements. The number of elements that an array has or an array contains. Okay, that an array contains. So basically let's look at a couple of definitions or a couple of definitions for some arrays. Like, want to define their sizes. Okay, so now let's say we have real, and we have dimension. We have real, we have dimension, we have 2,6, and let's say the name of this is, let's say, matrix. Okay, now the size of this array, okay, how we get the size of this array is very simple. Okay, now the size of the array is basically the distance, okay, the distance from the first dimension to the second dimension. Okay, the distance from the first dimension to the second dimension. That's what talks about. That's what defines the size. Okay, that's what defines the size. So basically, this is a two-dimensional array. This is a two-dimensional array, and if you look at this very well, now we have 2 and 6. Now the basic and the fastest way to actually get the size is to multiply the dimensions in it. Okay, is to multiply the dimensions in it. Okay, but now regardless of that, in this case now we don't really have decimals. I'll come to the aspect of the multiplication, but it's not with this particular one. Now remember, I said on the number line from where this one starts to this one, if you want to write this now, we have something like, let's say 2, 3, 4, 5, 6. So how many values are here? We have what? 1, 2, 3, 4, 5. Okay, we have 1, 2, 3, 4. So we have how many values here? We have 5 values here. Okay, so the size of this array now actually talks about from where the first dimension starts to where the last dimension is on the number line. Okay, now so it starts from here and it ends here. Now if we have 2, 3, 4, 5, 6, there are 5 values here, which means that the size is what? 5, because there are 5 values here, because we are talking about the number of elements that an array contains. Okay, so basically, if this is, let's say we have this as comma, we have 2, 6 here. The modern way of actually getting the size, now this particular way, like this now, is like the general programming way. Now let's come to Fortran. Now in Fortran, like I said earlier, the best way to actually get the size, is to multiply. So if you want to get the size of this, so see what we simply do is just to say 2 times 6. So this will give us what? 12. So that simply means that the size here is equal to what? 12. That's what it means. Okay, but this is a general programming concept. But in Fortran, we don't move on the number line. In Fortran, the size is by multiplying what we have in the array, especially when it is separated by a comma. Now if it is separated by a column like this, 2 column 6, that is when we will do 2, 3, 4, 5, 6, and the size here will be what? Will be 5. But general programming, especially very, very old programming languages, tends to even use this pattern to get the size of this. So like I said, if we have, let's say 2, 6, if you have comma, it means that this is a 2-dimensional. If you have column, it's still 1-dimensional. The only thing that will make you to actually say that a program, or let me say a description for an array, is 2-dimensional or 3-dimensional is when it is separated by a comma. If there is a column here, it means that it's still 1-dimensional. Okay, now this colon is used to specify the upper and lower bound of the array. So in other words, like I said, the array subscript lower bound here is the first, while the upper bound is the second. So it moves from 2 to 6 and it's a 1-dimensional. As far as there is a column here, it does not make it a 2-dimensional. It's still 1-dimensional. Okay, it's still 1-dimensional. So what does it mean? It means that in the actual size of this array, real dimension 2, 6, is what? 12. It's 12. Okay, so basically, another thing I need you to understand is that when we have a 2-dimensional array, okay, the first value here indicates the number of rows, while the second value indicates the number of columns. All right, so the first value indicates the number of rows, while the second value indicates the number of columns. So it means that this particular array has 2 rows and 6 columns. That's why we have 2, 6, 2 rows and 6 columns. Now let's look at another example. Okay, let's say we have real, then we have dimension, real dimension. Let's say we have 4, column 10 in this case. Okay, Then we have this, and the name of this, let's just call it that the name is array. Let's say the name is array. Now, do you know what this means? How do you get the size? When you have column like this, start from the lower bound, 4, 5, 6, 7, 8, 9, and 10. Then you count the number of values, 1, 2, 3, 4, 5, 6, 7. So what it means is that the size here is equals to 7. That's what it implies, that the size is what? 7. But if this were to be 4, 10, for instance, this will be 4 times 10, which will give us what? 40. The size will be 40. That is, if it was comma, it means that this will be 2-dimensional array. Why this is what? 1-dimensional array. This 2-dimensional array, this 1-dimensional. Like I told you, it is this comma here that makes it more than 1. Is this comma here that makes it more than 1? Okay. Someone is asking that, can we say dimension is equals to rank? Yes, dimension is the same as rank. Dimension is the same as rank. Now, what if we have something like this? Let's say we have integer, comma, then we have dimension, integer dimension, and we have, let's say, minus 3.2, comma, 0.4. All right. Then we have something like, let's say this one is, let's say we have numbers as the name of the array. Now, if you look at it now, you realize that okay, this is column. There is column here. Then there is also column here. Okay, there is column here, 0.3 column 2, comma 0 column 4, minus 3 column 2, comma 0 column 4. Now, this is a 2-dimensional array. Do you know why? Because there is a comma that is separating. This minus 3 column 2 is talking about 1 dimension. This is another dimension. Like I told you, 1 dimension can either be in column or just a number. If we have something like this, let's say we have a dimension, and we have in bracket 7, and we have another dimension and we have in bracket, let's say 4 column 6. These two you're seeing here are still 1-dimensional. Both of them are still 1-dimensional. All right, both of them are still 1-dimensional. But if this thing were to be 4, 6, this is not 1-dimensional again, it's 2-dimensional. It's 2-dimensional. So what you have here is a 1-dimensional array. This is another 1 dimension. So both of them now forms what? 2 dimensions. This becomes a 2-dimensional array. So how do we get a size? How do we get the size in this case? Okay, it's very simple. Now, what it means is that this first dimension starts from minus 3 to 2, while the second dimension starts from 0 to 4. That is, when we say minus 3 to 2, we say minus 3, minus 2, minus 1, 0, 1, and what? 2. While the second one, 0 to 4, 0, 1, 2, 3, what? 4. All right, are you seeing it? So the second dimension has 1, 2, 3, 4, 5, while the first dimension has 1, 2, 3, 4, 5, 6. So what do we do in this case now? There are 2 dimensions here. So the fact that there is a comma separating, we can't just come here and say the size is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Wrong. Rather, here has how many? Here has 6. Here has 6. While here has what? 5. So what do we do here? We just say that the size will be 6 times 5, which will give us what? 30. So it means that the size of this particular array is 30. Now, but if for instance now we had just integer, then dimension, then bracket minus 3 column 2. All right, minus 3 column 2. This is a 1-dimensional array. The size will just be 6, which is this. If it were just integer dimension, then 0 column 4, the size will be 5. But the fact that this is a two-dimensional array, it means that what we have to do is that we will get the size of this one and the size of this one and multiply by each other. We will multiply by each other. So 6 will times 5. So remember, I told you that in a two-dimensional array, we have rows. The first one is rows, while the second one is column. Now, while a one-dimensional array is just rows. So I want you to note it that in a one-dimensional array will have only rows, while in a two-dimensional array we have rows and columns. We have rows and columns. So I want you to take very good note of that. Okay, I want you to take very good note of it. I'll be giving you another example. We'll be doing another example right away. All right. Okay, so now moving forward. Now let's say we have something like this. Let's say we have real. Let's say we have real. Then of course we have dimension, and inside the array we have, let's say, minus 2 column 3 comma minus 1 column 2. Okay, minus 1 column 2, then close, and let's say the name of this particular array, let's say it's a relation. Let's call it relation. Okay, let's call it relation. Now it's important to note this, that if we have something of this nature, okay, it's the same thing that I explained. This is a two-dimensional array. Okay, this is a two-dimensional array with lower upper bound. What this means is that it means that the first one here, the first array here, is from minus 2 to 3, while the second one is from minus 1 to 2. So which means that we have from minus 2 to 3. Okay, from minus 2 to 3 we have, let's say, we have this, we have minus 2, okay, minus 1, 0, 1, 2, and what, 3. While the second one, which is 1 column 2, is from minus 1 to 2, minus 1 column 2, minus 1, 0, 1, and 2. So now how many elements are here? 1, 2, 3, 4, 5, 6. We have 6. Why here we have 1, 2, 3, 4. Minus 1, 0, 1, and 2. Minus 2, minus 1, 0, 1, 2, 3. So 6 times 4 will give us what? 24. 6 times 4 will give us 24. Right? So that's how we do it. Okay? So what it means is that this particular array has 6 rows and 4 what? 6 rows and 4 columns. That's what it means. 6 rows and 4 columns. Okay? I believe this is clear. Okay. So if we have this, it's important for us to write out what we have clearly and multiply, except we have, let's say, integer, then dimension, and we have, let's say, 4, 3. Okay, 4, 3. Then let's say we call the name of this array figures. Call the name of this array figures. Okay, so it means that we'll just multiply. We'll just say 4 times 3, and that will give us 12. This is the size, just like this is also the size. Okay, so that is it. So now basically that's for the terms that are actually used for arrays. Okay, terms that are actually used for arrays. Now you're going to be trying this for me. You're going to be trying something for me. Okay, let's say we have okay, what am I going to give you? Okay, let's come up with something. Okay, from past questions. Let's say we have integer, then dimension, we have 4 comma 3 comma 7, and this, the name of this is functions. Okay, then we have another one, we say real dimension, 2 column 5 comma let's say 3 column 4 comma minus 3 column 0. Okay, and let's say the name of this array is, let's say, is subroutines. Okay, so I want you to look at this and tell me the size or the sizes of each of these two arrays. So we have two arrays here. Like I said, the first one is the integer dimension 437. The second one is real dimension 2 column 5 3 column 4 and minus 3 column 0. So what are their sizes? I'm going to give you just 1 minute to figure this out and type it in the comment box below. All right, I believe you're here. I believe you can still hear. Okay, so I'm waiting for your answers to this. So I want to know the size. Okay, I want to know the size. I also want to know the rank. Okay, and I want to know the shape. If you can also tell me the shape, I would appreciate. So the size, the rank, the shape of each of these two. So anyone you've done, you can just type it in the comment box. Anyone you've done, if you've done the size, you can type the size. If you've done the rank, you can type the rank. Remember what I said about the rank. The rank is the dimension. The shape are just basically what is inside the array. Just bringing out what is inside the array. That's the shape. The rank is the dimension. The size is, of course, the processes I've given you depending on how the array is. Okay, so I believe you can still hear me. Okay, I just gave an exercise. I believe you can still hear me. If you can hear me, say I can hear you. Okay, I need to be sure that you actually heard the instruction I gave. Okay, if you can hear me, say I can hear you. So I'll be sure that you heard the instruction I gave about this. You can type in the comment box below. Just type I can hear you if you can hear me. If you can still hear me, say I can hear you. Okay. If you can hear me, say I can hear you.